Good afternoon, everybody.
Tá bem.
Today we are here to talk about digital twin with meta models, and hopefully to clarify some doubts and have the opportunity to discuss about this topic. So my name is Sara Inácio, and I'm responsible for the research and development team management at QuiJest. And with me, I have Daniel Silva, who is the Global Solutions Senior Specialist, also at QuiJest. During this hour, we will start to explain what is a digital twin by giving several examples. Then we pretend to show you how meta models can be related to digital twins by presenting Vivi, a project developed specifically to respond to the COVID-19, taking into account the necessary agility. At the end, we will briefly present QuiJest and what we do differently. Finally, we want to open the discussion and answer the questions you may be asking in this Q&A section. Okay. So, having said that, Daniel, feel free to start your presentation.
Thank you, Sara. Good afternoon, everybody, again. So, we come to our meetup, so trying to explain or make sense of what are digital twins. So, there are many definitions of what is or what can be a digital twin. So can it be a model? Meaning can we do or can we make a representation of something that is real and turn it into a digital representation? Another term that is closely associated with digital twins is Internet of Things. So we've seen in previous years a great boom in terms of this buzzword, in terms of getting that information in data collection. And then we see the transition to a term that is fairly recent, that is Internet of Behavior. And we can say it's like the upgrade or the consequence of the Internet of Things. So when we are talking of digital twins, we're talking also in Internet of Behaviors and how the data that we have collected on the Internet of Things, on our gadgets, on our movables or wearables, can be used to map, to model our behavior or the behavior of the system. Another term that can be used in terms of digital twins is the term of simulation. One of the key aspects that is associated with digital twins is deep learning or artificial intelligence, in terms that we are using our information to model, to predict, to optimize our view, our digital twin, and therefore gather the information that will help us in our real twin. Another term is augmented reality. So we've seen with the evolution of how we interface with systems, the ability to use either virtual reality or even augmented reality to control and to create an interface with our digital twin in order to zoom in or zoom out into the characteristics that we find more relevant and do we want to drill down upon. Okay, so there are plenty of terms that we can use in terms of the digital twin. It's kind of like a Superman version of what we've been doing for so long in computer science, and trying to map out reality in terms of a digital approach. So I want to point out this example, and on the picture on the right, it's a NASA storage, and if you and the picture on the left is a still frame from Apollo 13. I thought this is relevant because NASA, although it's John Vickers has put forward in 2010 the concept of a digital twin, has from its conception used models and used real models in terms of creating a framework to optimize, to try and map out reality in different scenarios. And in the case of Apollo 13, if you've watched the movie at least, there was a problem with the space shuttle while in space. They had a problem there, and they had to rely on the astronaut that was left at home with chickenpox, I believe, and he was then sent to the model, the real model, in terms of trying to determine how was the sequence, what the sequence needed to be in order for them to survive and to have the ability to return back to Earth. So this concept, this real life approach from a model, is something that we now can see with the evolution of technology, of course, being transposed to a digital twin, to a digital representation. But there are twins and there are different kinds of twins. So on the left, we have the real twins. So we have many similarities, both in appearance and also in DNA. And then, but we need to be careful, otherwise we're going to get to that kind of twins that we saw in the Arnold Schwarzenegger and then in the video movie. So the approach of the digital twins is something that needs to be not taken lightly and must be analyzed in accordance to what the requirements are. So trying to sum it up a little bit, so we can say digital twin is a virtual model of a thing, a person, a process, or a socio-economic reality that accurately describes current operations and may also predict future performance for a variety of scenarios for the purpose of optimizing decision outcomes. So this is going back to a little bit what I said. So we're trying to model the reality, but giving space and trying to create a framework that will enable us to test different scenarios, and from those different scenarios, try to find optimal paths and try to find optimizations. So there are 3 points that I would like to focus as we identified as being keys in terms of how we start in building this digital twin. So we need to understand the primary and secondary sources of information. Okay, this is why also digital twins is closely associated with Internet of Things and Internet of Behavior, because data collection helps us get the prediction and enables us to get the evidences required for data prediction and for the model to be optimized. So we then have to identify from that data, and we see big chunks of data and big clusters of data. We need to really identify what is critical to our decision process and what is relevant information. And in that part, interface plays a big role in that aspect. So, and then we need to represent scenarios in simulation, either by something that we have experienced and afterwards try to figure out what went wrong or what went right, but also in terms of consistency and testing. One of the biggest applications we see in different forums for digital twins is regarding airplane construction. And in airplane construction, it's not just a question of optimization, but it's really a question of security and of safety, and how that safety can actually is critical, because we want to minimize all the possibilities of a plane crash. Okay, so having the ability to test different scenarios and trying to put it forward to the process, the building process and the optimization and maintenance process is key. On this slide, what I'm trying to represent is how interface has enabled us to try and select key points of key indicators, and from those key indicators try to get the maximum information. With deep learning and artificial intelligence models, we are then able to put forward scenarios, trying to get how that information was obtained, so getting the references to see how well of a prediction, how secure of a prediction the model is trying to give us. And this enables us to put forward innovation and put forward solutions for our problems. Another issue, for instance, or another example, I've put this slide here from the European Space Agency. So this is a simulation that simulates different scenarios, and in this case is trying to simulate how to divert a meteorite that was going to hit Earth. We're seemingly on the movie side of the presentation, so probably everyone has seen Armageddon or seen other those kinds of motion pictures. And the simulation here is how can we divert a meteorite with a probe that is already in space, and trying to get those scenarios forward and trying to anticipate any problem that we can face in that regard. Another example is concerning healthcare. Okay, we're going to touch on Virvi and explain it a little bit. And Virvi is also built or designed in the healthcare department, let's call it like that. But one of the things that hopefully we can put forward, and hopefully we can help science and healthcare, is by using digital twins to anticipate, to train for physicians, to try and predict the outcome of procedures on those patients, and also trying to correlate multiple informations from multiple exams, from multiple diagnosis machines, in terms of getting the whole picture and getting a picture that is fully integrated. So what we are facing now, or in most of the hospitals, is we have degraded information, meaning that we have exams from multiple sources, but there is no real correlation. The correlation is all performed or executed exclusively by the physician. So hopefully we can get to that stage where the physician can have a much more wider view, a more correlated view of all that information. But not everything is perfect with digital twins, more so because we're still in the, I would say, early mid stages of digital twins. Okay, so there are issues in terms of the prediction, in terms of how we establish that correlation. For instance, on the left, you will see that there's an issue, a security issue in terms of correlating our facial features to criminal aspects. Okay, so this is something that we've seen nowadays, and we do all have seen those apps that come about and have us change our face and getting older, getting younger, changing gender, whatever, and all that builds up for our database that usually goes for that kind of prediction. Okay, but that prediction, those assumptions are all are not risk-free, let's call it like that, because there is a factor of uncertainty that is associated with it. Another problem is regarding, and I call it on the right. We've seen it on various cases. We saw it in Spain, where on the 25th of May, it was observed that the data collection stage was not so well established, so meaning that the numbers of cases that were counted were much more than there were in reality. So we had a decrease, and this looks very strange when we were looking at the evolution graph of the pandemic. In Portugal, we had a case where we had a build-up for a weekend, and then the data spiked on the Tuesday because they didn't collect and didn't make available all the data from the weekend. And so when we're dealing with reactive and very much open real-time evaluation and decision making, then it is important that we get all these systems right. So let's go for another point. So how can we at QuickGest, and of course we're going to put forward a little bit of our approach here in the digital twins, right? So what we want to do is trying to get or build the bridge between the entities and the business decision and system support, right? So we have our reality, we have our physical things, our people, our process, our social economic dynamics. So let's call it our real world problems, and we want to get to our system, to our either by our system, information system or decision system or modeling there, and try to build up our digital twins that will help us evaluate, map, and try to enable us to get more critical decisions with better information. So it's always a question of data versus knowledge, and that's the path that computer science has been working on for quite some time. And digital twins is, I would say, putting it forward, or meaning it's trying to make it real, trying to make it effect. So what I wanted to talk to you about also how we, one of the examples that we did in terms of the digital twin approach. So when exactly on the day that the emergency state was decreed here in Portugal, we just started to build a solution or that used the concept of digital twins in order to provide a response to the pandemic. So in 2 weeks, we were able to create a model that could actually function as a framework for the many stages of the digital twins construction. So again, we started with the data collection that would enable us to create the information that would allow the coordination and strategy-based approach, then provide the response and enable the response and facilitate the response for first responders, meaning for helplines and health lines on our country, but also then go the extra mile in trying to figure out how that information could affect the supply chains and how could we, in a more knowledge-based process, supply materials that were scarce. There were that were not that much available to us. Okay, so in terms of the data collection, we decided to let's try and develop this digital twin, this representation. What is our national-wide map of entities and professionals, trying to register infections, tests, known links between individuals. Again, we all on that stage, and in the first step, we are all trying to understand, as we are now, how the virus works and how it affects us as individuals and us as a community. And so we design our system with the ability of being an agile design and being a system that we could evolve and get information across as we get it and as we know how to use it, or at least we have an idea of how to use it. Furthermore, we decided, let's do this in an approach that that can be sufficiently agile and sufficiently open, that it doesn't restrict to COVID, but can be applied to other pandemics and can be applied to variances in the virus. So we needed to be sufficiently agile and sufficiently open-minded in terms of how we would map this in order to not create biases in the system that could hinder us going forward. And then one of the key aspects, and if you don't mind me saying, probably one of the key aspects that is lacking in many countries, and we see it not only in Portugal but in various other countries, is the coordination, the effort coordination with data. So because we don't have a structured data source and we don't have something that could actually give us valuable information in terms of how the pandemic is spreading and what are the key components here, and trying to drill down that information, we do get more into a stage of trial and error, okay, more than probably we would need to be. Of course, there would be always a trial and error because we are working with something that is not completely studied. But what we were doing was probably going more blind than we could be in that point. So coordinating efforts, it was a big part of what we envisioned for Virvi and for our digital twins approach. Another key issue is to getting the optimization. So what we set out to do was to develop this solution in order to help responders, first-line responders, get a sorted list of people of the most critical cases. So we all are faced with the news, and especially in the early beginnings of how we were attacking the pandemic, that a whole lines were filled with requests. So there wasn't enough manpower to respond to all those requests. So it was very important from our perspective to identify what were the critical cases and what were the critical factors, and on that try to build up our response system. So we develop, again, it's the digital twin approach, is getting to the data, trying to correlate it, evaluate different scenarios, and then try to build upon those predictions, those evaluations, and optimize the model, optimize the path in order to get better results. And basically, this was the Virvi approach. So this is not something that is really strange for QuickJust, because I think we always modeled and try to model the reality as closely as possible. But the digital approach, and this is probably the message I want to stop my presentation right now, we're going to move forward, is data is very important. How we treat that data and how we model things and how we go forward is extremely critical. And digital twins can play a very important part, a very important role in that optimization. And now I'm going to, let's not just slide. So we're going to talk a little bit, Sarah.
Yes, Daniel. Thank you so much for your presentation, Daniel. It was a very clear way of presenting a concept that can be quite abstract, right?
Yeah.
So starting our brief conversation, I noticed that you talked about not so positive aspects of digital twins, and I would like to talk about that. So regarding that, what do you consider to be the main behavior impacts of the digital twin?
Okay, so starting with, let's start first with the issue, so the concerns, and then going forward to the benefits. Okay, so when we're designing a digital twin and we're designing this implementation, we are looking at a specific snapshot of our reality now in our data. Okay, so either by using models or predictions, we can actually be putting forward some bias into the system. Okay, so getting and understanding that this is always going to be a work in progress. This is something that we're going to build upon, that we need to get that information across and build the system is very important. There are no quick fixes to major problems, okay? And the digital twin is something that will probably be used in major problems in regulatory affairs, and something that needs to have a wider scope and a wider view of issues. So it is very important to understand the information we have, respect the information we have, and build upon it, okay? In terms of its capabilities, I think it allows us to remove the feeling part of our prediction. So of course we have that in the human aspect of it, of having that gut feeling that something should go this way and making that decision based on our assumptions is very much a human thing, okay? And probably it is still very much a human thing because we don't have the data structured in a way that we can actually get that information across, okay? So one of the things that that hopefully we can get to is getting that full model thing, that simulation thing on, in order to move forward. Okay, so on the one hand, the issue is biases and assumptions that can actually be very detrimental to us as a society in terms of privacy, in terms of issues in regarding our well-being, our safety. Okay, and the positives is that we can test various scenarios and we can use the information that is collected from multiple sources in a much more interesting fashion.
Thank you. In fact, it is really important to be aware of the positive and negative aspects of this, right? So we can avoid some risks when using digital twins. So, okay, next question that I would have to you is related to our job in a way. So as specialists in the development of information systems, we are quite aware of that some solutions do not completely correspond to what is intended when they reach end users, right? This is a well-known risk in the technology market. We know that, we work with that. Sometimes we realize that the initial perception of reality was not correct, and other times the reality itself can change. It's normal. So would you say that digital twin would have the ability to evolve and transform according to these needs?
Yeah, I think so. I've read, and this is a topic that is kind of a hot topic right now. And one of the concepts that is also associated with digital twins is a digital thread. And the digital thread, for me at least, for my interpretation of it, is closely resembles something that we've worked with for a long time, that is an agile methodology, in terms that we do have that plenty of iterations, and we do map out the system, and we define the requirements, and we model it. We test it, we evaluate it, and then we go back to the beginning of the cycle and go again for it. Because Vivi is a good example on that, and I think I touched on it a little bit. We didn't know exactly, and none of us knew what this virus was and how it worked, and so we tried to put forward an approach that could be flexible enough that our information, the information that we had, was not set in stone. So we could actually change our model, adapt our model, evolve our module, and I think evolve is right the word, and you use it also, Sarah, and I think it's very accurate, in order to get to a stage where we increment knowledge, we increment the way that we are building our system to get a more robust and more accurate or precise model that, or representation of the reality. Okay.
Yes, and for that, speed was a really important factor for us, right? Because we needed to get the response really quick regarding the situation. And how do you think we could manage that? I know the response, but I would like you to.
Okay. In this kind of situation, and in most cases, you have to sometimes get the approach of breach of going for the breach. Meaning, sometimes you have to be a little bit crazy and storm out and try to go by yourself and be the trendsetter, be the one that falls on the journey, because that will enable us to create the twin and evolve our system. And then if we want to go further, then we have to go for the approach, and we have to have the experts and have to build upon that. So I think it's a two-way street, or not a two-way street, but it's a two-way iteration here that you probably have to go it alone on the first stage. But then, as a community, as a set, we have to build our information, our twin, as a family, let's call it like this, and build it up in order to get a more robust response.
Yeah, and it was also possible because we at Genio, right? So yeah. This platform that we developed at QuiJazz that allow us to develop information systems so quickly, right?
Yeah, I guess, I don't know if we'll call it fortunate, but because we have a model-driven approach here, that by itself enables us to try and refine the model and trying to get that approach on. So having that ability to go a certain way and then not have to start all over again from scratch, but consolidate our model, I think it was critical in getting that system, that version, that release off so quickly as we did. So in that regard, I would say Genio is a great tool in that sense. So I don't know if you want to go, we can go for the Q&A. We have some questions here. Probably we could tackle them before we move forward. Okay?
Okay, sure.
So we have a question. So for this work, digital twins, is it required a huge amount of data? Okay, so this is a very interesting question, because Internet of Things and Internet of Behaviors, we do see it as a data consuming aspect, and predictions do require pretty much a very big chunk of data, or a very big cluster of data. However, I would say that in designing the digital twin, in taking those first steps, the data is more of not step 0, but step 1, because we're trying to model it, and then we're trying to adapt it to the information we have. And that makes our iterations, our cyclical iterations, be much more relevant here. So I would say that the amount of data that we can use to start doesn't require to be that big of a data sample or data set, but moving forward, of course, a bigger data set, a more heterogeneous data set is very helpful in terms of the prediction, because it gives us the sustainability in terms of our prediction and our model. We can query the system of how how accurate or how confident it is in that prediction. So the data that we are gathering then becomes gives us an increased level of responsiveness here. So another question here is, good afternoon. Do you consider ways to speed up the process to obtain data about a product you want to model with digital twin? Yeah, this is also a very, very good question. So, of course, if we want, in terms of, for instance, let's go with the coronavirus pandemic. Of course, one of the key issues was to be pretty much responsive and to create a setting that would enable us to obtain data and to get that information as fast as possible, and to create an interface that was very intuitive to use, very easy to use. So it would enable us to get the people using that data and will help us go for the next iterations. So I think we have to think always on the system and optimizing it, and interface plays a big role in it. And gathering, and the way we gather that information is very helpful. So again, with Internet of Things and Internet of Behaviors, what we're looking for is a seamless way to gather that data. And to gather that data, if we do it in a seamless kind of way, we can achieve two things. One, we don't bother the users. Of course, they give us their consent when they're providing the information or using those wearables, but it doesn't become a tedious task for them. So it's not something I have to do, it's something that I am doing. And another issue here is so the Internet of Things, so getting that information, and I lost my train of thought. I was saying I was going to say something else, but I forgot about it. So
I could edit like on the Vivi project. We thought a lot about physicians and health professionals who were using the platform. So we almost had to think like we were them, and we had to create a solution that would be so usable that they don't have to make a lot of effort to do that, because they are in stress. The situation is already bad, so they have to. We want to help them and not to create more effort for them. I don't know if that helps, but I remember that was one of our concerns.
Yeah, right? Yes. When we were designing the system, one of the things we thought, and sometimes when we were explaining the solution, it's something that we were queried about. So we designed the systems to be as easy to use as possible. Okay, so very clear interface in terms of data collection. And some of the questions we had is, but how do we input this much information and the other information and that information? Because there was an urge to dump all information that we could have there, and then we try to figure out what we could do with it. And that can be an issue there, because, like I said earlier, in terms of designing a digital twin, we need to at least have an outlook of what the information is, how to correlate it, and how to model it in a sense. And now that sorry, I remember what I was going to say. What was the second point? It was in terms of the interface, and it was precisely that it needed to be something that could be easily used by professionals that were completely underwater, that didn't have time to do much of systems discovery. They were basically we had that conscious. They were their first, their second, and their last goal was to save lives, and a system shouldn't work as an additional weight. It should help in that sense. So it should be something that they could do seamlessly in terms of how they use the system. And the digital twin is also that it has to be something intuitive and something that can bring knowledge, but not be a load, an extra load in how we are operating.
Exactly. So, do we have any doubts?
Any questions? So you are free to please use the Q&A. Any questions that you have. We're going to move a little bit forward on the presentation, right, Sarah? And then we'll sum it up a little bit and open again to Q&A. So feel free to pop any question that you want, and we'll get back to you.
Yeah. So I will move on because we don't have a lot of time. So in conclusion of today's meetup, just a moment. It would be important to demonstrate how QuickJest's methodology responds to our digital twin challenge. Am I sharing the screen?
Yes, sir.
Yes. For this, I will start by briefly introducing who we are and why Genio stands out. Okay. So here at QuidJest, we are applying automation and artificial intelligence to software development since 1988. QuidJest is composed by 12 specialized teams which developed solutions that provide digital transformation to our customers. With more than 200 success cases and 32 years of expertise, we are able to create a solid network and of national and international partners. All of this is possible because we developed and are constantly evolving our extreme low-code platform named Genio. Through artificial intelligence, Genio automatically translates a model into code, allowing the continuous improvement of our solutions by taking advantage of agile principles. Okay, in this way, Genio proved to be 10 times faster than manual code, requiring less resources in development, which is a pretty big, quite important thing for us. Having said that, we are really enthusiastic about giving everyone the opportunity to use Genio and apply it in the development of a solution that solve digital twin challenge, for example, and other things. One of the steps to achieve this goal can be participating in our academy, which is designed to respond to several types of profiles, as you can see on the screen, depending on your goals and needs. If you are curious about what genotype would you be, you can simply fill out this form, whose link will be available on the Q&A section right now, I guess. And you can also have the opportunity to give us feedback about this meetup, which is really important to us. So, having said that, we officially open the Q&A part. So we already answered some questions, but I have a few more to you, Daniel, so we can keep talking.
Let's
okay.
Go.
So Daniel, you talked about a lot of examples, right? A pandemic example, space travel example. Do you have any example for us that could be more, I don't know, not real, you know what I mean, but a business which we can use every day, or a business really common in our daily lives?
Okay, so I would say that a digital twin approach is not an approach. It's not something that solves every problem. So it's probably we have a saying, it's like killing a fly with a cannon. So it's not really an approach that fits all problems here, right? So, but it does fit strategic and decision-making problems where you have you have plenty of correlated data, you have plenty of interactions between entities, between stakeholders, and by mapping it, by modeling it, you get to optimize it and you get to have that kind of information. So, for instance, if you're talking about some regulatory institution, for instance, where you have multiple dependencies on that regulatory entity, you could actually use that data and get the digital twin approach to evaluate and to optimize the relation between those entities, and to get a more seamless interaction between them, in order to accomplish your goals. So there are plenty of approaches in that sense. We have KPIs, we have balanced scorecards. There are approaches that have been used in that sense in terms of getting that information and getting that strategic part forward. But all that information can be, I will say, upgraded, can be taken to a new level, probably with a digital twin approach, because it enables us to get even more out of that kind of interaction. So I would say it's not exclusive. So we're not putting out the balanced scorecard or the KPIs into the trash, but we're actually building on it and going putting forward. So I think we have a question here. Can KPIs help the digital twins? I believe so. I believe KPIs can actually help us design and can actually be part of the digital twin process. So all those kinds of approaches are not going to disappear, are not going to be muted. I think they're going to be upgraded. They're going to get a boost from all that correlation, from all that artificial intelligence, that deep learning, that data correlation, in order to get a version that is much more knowledge-centric or knowledge for knowledge outcome. So I think KPIs can help digital twins, yes.
In fact, all these concepts can be related, right? Like, we talked about agile principles because it's an essential part to a digital twin if we want to go fast, to work fast. What do you have to add to these thoughts?
Yeah, because agile, well, we were working in the IT sector, and we are faced with it on a daily basis. And for someone that has managed projects, even if not in an IT sector, what we are faced is that the requirements that we start the project on are not the same at the end of the project, and even they're not the same probably 1 week after we start the project. So in terms of designing the digital twins and evolving the digital twins, we are faced with the same issues. So by having that agile approach, by creating a space and creating a model that and being model driven in that sense, and trying to be flexible in that sense, gives us an immensely wide range of possibilities, and in terms of the evolution, and reduces plenty of the restrictions that we can have in terms of designing that digital twin. So agile is very interesting. It's a very interesting approach, and I think it copes well with this kind of approach for a digital twin. I think they are, for a lack of better words, they are very complementary in terms of how we're going about it. Okay.
So we have another question, right?
Yeah, what is balanced scorecard? Okay, so balanced scorecard is an approach that enables us to define objectives, and for those objectives, those perspectives, we then define indicators that help build and evaluate those objectives in order to how to reach them. So if we're going for the digital twin and how they can correlate with a balanced scorecard, we can actually design the digital twin in order to set up our objectives and our goals, and then determine our indicators, and those are the key features or the key aspects that we are trying to optimize and simulate on our digital twin, and get more precise information of how we're feeding that indicator and how we're feeding that objective and reaching that objective. So it's an approach it's an approach that is very simple. I would say simple to use, not that simple to explain in a short amount of time. But be sure, I'm going to put a marketing hat on, and be sure to follow our Balanced Scorecard approach in our QGIS website, and you will find plenty more information in that regard.
And regarding digital twins, it's almost important to have real-time indicators, right? Because we need to act fast. We need to react fast. We need to change process anything fast. So we need that these KPIs that you mentioned are available almost in real time, right?
Yeah, the response is critical here. So we need to have in the era we live in. We must be very proactive. It's not even a matter of being reactive, because that makes us lose our advantage, our edge in terms of our response. So if we are fixed and we are centered in the specific pillars or constrictions, then we're not going to go forward and not going to evolve. So having that ability for a quick response, it's very useful and it's very important. Okay. So we're being asked for more examples of a digital twin in business. So I've touched on the regulatory aspect. One of the most saying the most common is not really the best way to phrase it, but applying it on the production line, it's very interesting, especially if it's a long production line. It can be very interesting because you have to work with supply chains, you have to work with the full length of the production line, you have to look at labor, you have to look at automation. You have plenty of factors on that line that need to be managed and to get that information. This is kind of an operational research problem, but it's an operational research problem that can be mapped and designed into a digital twin. And after that, we can manage that production line in order to get a more efficient product line. So one of the things that can actually detriment in terms of the production line is stockpiling parts just because not to keep idle. So this is one of the key issues on production line is sometimes you have bottlenecks, and one of those chains has a productive capability that is much greater than the critical path of that production line. So commonly, or in many cases, you get to build up worthless stock of parts that doesn't really translate into a value into a business. So digital twins here could actually give either floor managers or top managers a sense of what the bottlenecks were or are, and working on that sense in order to streamline the production into a more cost-effective basis. Okay. Another example, probably, and something that is dear to me, is in terms of healthcare. So in healthcare, digital twins, I think we're going to I think the ultimate goal is to go for something that I also showed in the presentation, that is digital representation of the human body and the human system, of course, all the correlations, and getting that information either by wearables or by specific diagnostic machines, and trying to help us on a day-to-day basis and getting that information, and but also bridging that information for doctors and helping them get forward a more precise diagnosis that can be helpful and reduce clinical error. And clinical error is something that is very critical and is very, unfortunately, can be very detrimental. And having that information and having that capability of putting forward that information is very useful. On the other hand, and this is something that is being discussed probably in the ethics committees here, is that we're going to go to a point that probably physicians won't do an autonomous diagnosis, because if they don't go the way that the algorithm is predicting, even more if it's a fairly high and accurate precision, they're probably going to be subject to further liabilities in terms of process suits. So there's something in terms of the healthcare part that is debatable, and I think it's still going on in the ethics committees on plenty of hospitals.
Yeah, that's a really hot topic, right, Daniel? I think we would need another hour to discuss that. But at the end of the day, the main purpose is to help physicians and health professionals to make a decision, right?
Yeah.
So if we can do that, I don't know. I'm not partial enough to talk about that, because we help on that decision, but it's a really interesting view. Thank you, Daniel.
Do you have time for another question? I think it's the last one we have here. I think we still have time for it. So, how does QuickJust help clients and governments to implement digital twins? Okay. So this is I think for us at least, our approach for digital twins has not, or the advent, let's call it like that, the advent of digital twins has not changed pretty much of how we do things. Like Sarah said, we're a company that has been established since 1988, and Genio, as our model-driven software and our model-driven framework, has been developed and evolved throughout I would say, if not since the beginning, so pretty much the beginning. And so our approach was always an agile approach, okay? And that agile approach is just being augmented by how we can implement new technology and implement the data that our systems already gathered in a very model-based approach, okay? And try to build upon it and create those systems that can help provide that information. So creating a system that can actually help not only on the operational level, but also on a decision in a strategic level, based on information, based on data, and based on correlating that data. I don't know if you want to add something, Sarah, and that's.
I think you said it all, but yeah, I would say that we didn't choose to create solutions with digital twins. We already done that. Like we already do that. So it's like we realize that we are doing that. It's more like that, I think so.
But probably because you are in the R&D team, you can talk a little bit, because I believe that our approach in R&D is also that. It's just we have our base and we augment it with further capabilities, but always focused in bringing value and bringing information to our system, right? So that's, I don't know if you want to talk a little bit on that part.
No, that's completely right. Like we Genio, right? We develop almost every patterns of Genio, and to do that we have to think about the client, we have to think about the user, and we really need to create a scenario with the possibilities. So yes, it's a digital twin itself, I would say.
And the good thing is because we work with patterns, right? We get to get the experience that we get from other implementations and build upon it and just evolve it. So we don't see a project. A project is, or an implementation of our system, of our digital twin, is helping us go for the next implementation or the next version. So it always helps us increment and have that iteration-based approach in how we deliver that implementation in those digital twins, right?
Yeah, and because our deployment is really quick, right? Like our internal clients can use actual Genius latest version, and they can test it, and they can say to us that there is a bug, and then we can fix it. So it's a really agile approach within the house. It's really, I think we do it almost without knowing that we do it.
It's so ingrained. It's so ingrained in how we do things that we don't actually stop and think, oh, we're implementing digital twins. For us, It's just like they say, it's just another Tuesday. So it's not even something that goes so natural, and we seamlessly went that way. And when we stop and try and look at what is actually the digital twins, we can actually find plenty of common ground with what we are doing probably 10 years ago or 15 years ago in terms of how we're designing systems. Of course, technology has changed, our approach has changed, business has changed, problems have changed, but the concept here and how we were building to get to this stage, I think it's always that, is building block by block and getting to the point that we are right now.
Exactly. I couldn't agree more. So I think we just finished, right?
Yeah, I think we ran out of time. It was much quicker than we probably were thinking. It's good. I think it's a good sign. We hope everybody enjoyed the meetup, and we're going to have more meetups that we're going to be organized by Quiches. So be sure to follow us and follow our meetups, our next meetups.
Just to add one thing, anything you need or any idea you want to share with us, you can contact us through these emails, okay? And I think that's it. Thank you everyone for watching this meetup. I hope we can see you on the next ones.
And hopefully we can get to a meetup that it's not just remotely. It will be a good sign, right? So hope to see you again, or at least participate in hearing from you guys. So any questions, feel free to send us an email, and we'll get back to you as soon as possible. Okay. So thank you everybody.